Hi, welcome to my channel. In this video we will show the demonstration and analysis of a very important machine learning algorithm which is known as artificial neural network, and which is known for its accuracy or accurate predictions, be it classification or regression problem. For that we'll be using a data set that is known as newann, and it is a very small data set just consisting of 60 rows and 7 columns, and this is our target variable or the response variable yield. It is continuous in nature, and all these rest of the 6 variables, fruit length, fruit print, fruit size, fruit weight, fruit volume, or fruit set, they're used as explanatory variable and yields our response variable. So we have a regression problem here. So in order to proceed, what we need to recall some libraries here. The first one is a default one, neuralnet. Then the second one is again a very important library which is used in this in performing or fitting this, that is known as caret, which is used for just cross validation. And this another library that we have to recall is tidyverse for predictions, and the last library, which is highly recommended, is matrices to get the values of some important selection criteria like root mean square error and a very important prediction error rate. Well, the first very important step in case of fitting of any machine learning algorithm is to do the data standardization or normalization, either using the standard normal variate procedure or just by using the minimum or maximum procedure, where in a particular variable we choose the first data point, then subtract it with its minimum value with a reciprocal of just the range, the largest and the minimum value. So for that we have already made a function to do the normalization. So this normalization function is done. Then what we have to do, we have to apply this normalization function on our data set. For that we'll be using as.data.frame, and we'll be applying this normalization on newann so that our data will be standardized. So we'll just click on this run. So we have a new data set. The original data set is newann, and the new data set, which is a standardized one, is newann. Let us see the first few rows and first few columns of our new data set. You can see this is our original data set and this is the standardized data set. If we will take the example of this yield variable, you can see the first observation or the first data point in this yield was 82.17, but here the yield, the first observation is 0.06, and you can see almost all these variable, the observations are very close to each other. We have made them standardization so that since we have the variables which are measured on different units, so in order to put them on a common scale, this standardization is very important. And if we will not do the standardization, it will have a very drastic or a very impact on our final predictions. So our predictions will not be as much as precise as we used to expect from our algorithm or the model, whatever the stuff we are using. And the next step is to do the appropriate cross validation. Since we have only 60 observations, so we'll be using a function that is known as trainset, just to give the name to our first part of our data set, is equal to, then since this is our standardized data set, then from we are just using a T20 approach, the first 48, or rather than randomly selecting the 48 data points or observations for our training set. Similarly, we'll be using a test set. Say for example, we're giving this name test set is equal to newann, and we're using these square brackets from 49 is to 60. So cross validation is done. The next important step is the fitting of this algorithm. So we'll be using a name to a function, and we'll be using a default function here, that is neuralnet, and within this neuralnet, what we will do, we'll first write the name of our response variable, that is yield, and this tilde dot comma, which is a short function, which I have already discussed in my various videos in context to machine learning or correlation and regression concepts. Then data, since we always used to fit our algorithm on our training set, so we'll be using this train set here. Then hidden is equal to c2 comma 1. Now this is very important stuff. Since this neural network consists of different layers, we have 3 layers in fact: input, hidden, which is very important, and the output layer. And here we are using just 2 hidden layers, and in first layer you're using 2 neurons, and the second layer only 1 neuron, just to make it simple. Then after that we'll be using one more important function, linear.output. Since we have a data which is actually from biological phenomena, and we always assume that they have a non-linear relationship, so we are seeing the effect of all these variables on the response variable assumed to be non-linear, then giving a certain kind of a threshold, which is very important since this is an iterative process. So we are expecting that a change in error less than 0.01%, so the iterations will stop, no further iterations or will be done. So just we'll click on the enter. Then now we have 2 options here. Either we can directly get the plot of this or which is known as a black kind of a black box, where all these network kind of a plot will get displayed, or we can get the result. So let us start with the results first. NN $, then we have neural results, or we can see the results also. We have a result. We want a result of matrix for the fitted algorithm. So we have the results here, which looks a quite difficult one, but it is very easy to interpret if we will just plot this function like this. So we have a plot here, and you can see the overall error is 0.07, and it is visible here. The steps that we have been taken, or that steps involved while performing this neural network are 207. You can see the steps are 207. The threshold reached is 0.07, and you can see that from intercept to hidden layer first it is minus 5.6, and from fruit length to first hidden layer it is 6.55, and you can see this is nothing, this is the weight, this black line. Then if we will see the fruit breadth to first hidden layer, it is 10 point something. Fruit breadth to first hidden layer is like this, and like this you can see the weights on these black lines, and these blue lines are nothing. These are similar to the intercepts, which I have already discussed in one of my videos regarding fitting and validation of neural network, but that was only for volume prediction, where we only involved 1 response variable and 2 explanatory variables utilizing diameter and height. But this function, this can be used for performing the analysis of any kind of data set if that data set involves a large number of variables. But one more important thing which I would like to mention here, that since here if you can see we have just used the combination of hidden layers on our own. We have not used any kind of procedure here how we can conclude only 2 hidden layers is to be involved within this ANN fitting, or only 2 neurons in the first hidden layer and only 1 neuron. For that we have to tune this ANN model. For that I will be making a separate video that is regarding how to tune or how to do the hyperparameter tuning of neural network. But this is actually the default way how to fit a traditional algorithm. But here we can also add some another thing, like we can also use the activation function. Although the detailed thing about this activation function will be done in the separate video which I'll be making on the hyperparameter tuning of ANN. And within this I will write logistic or you can find it out in this help option of this. You can find out we can tune the different parameters, choose the different combinations of hidden layer, choose the different combination of threshold, or we can use the step mass function, or we can change the values of learning rate, or if you will see we have to use the procedure of back propagation or feed forward, which I will discuss in that video. And here activation function by default we can use logistic or tan or sigmoid depending upon the what kind of problem you are dealing with. So if we will use this activation function, let us see what will happen. Then this act.function, you can see here we have done a mistake here. Simply now we will click on this. So we have, let us make a plot of this. So here you can see the error is 0.103, and in case of the first one it was 0.07. so clearly if we change the activation function, the predictions, or we can say the error which is involved in this fitting, it gets changed. Now the important thing that we have to do is to do the predictions, and for that we'll be using this default code, that is predict. Since predictions are usually done on testing set, for that we will just click on this. What we have done here, we have just extracted this model or used this model, and for that we'll be using the testing set, since this testing is always done on the predictions are usually done on testing. Then in order to get and if we will see the predictions here, these are the now predicted values of the rest of the observations. Then in order to fit or to get the values of R square, we'll simply use a data frame. And here this is very simple, since I'll be giving the functions in the description of my video also, or these codes will be available on the description of my video. I will just click on this run, and you can see the value of R square is very good, 0.97, and root mean square is quite low, and prediction error rates are 0.2. and if we will quickly here use two hidden layers, two neurons in next hidden layer, let us see what will happen to the predictions or the predicted values of these. And you can see the predictions are quite same, the R square is quite same, and in fact it is a bit increased, and here the root mean square is a bit changed. Prediction error are somewhat similar. Again we will change it from 3 to 1. Then we will see what will happen to the predictions here. Quite similar. So there is not so much change, but a bit the values get a bit changed due to the change in the combination of these hidden layers. And if we will again change it, say for example we will write it 3 to 5, then do the predictions again. So you can see the R square is quite similar, root mean square is quite similar. So two hidden layers are quite good, and just we have to change the number of neurons within the hidden layers. For that I will be making a separate video how to tune, how to fix the number of neurons or the combination of the neurons within the hidden layer. Hope you like this video. All these functions or these codes will be available in the description of this video, and the next video that we will be making, that will be based on the hyperparameter tuning or the parameter tuning involved in fitting and validation of the ANN algorithms. Thank you very much. Hope you like the video.